One thing I think you all know is pretty simple, that if you multiply a vector by 2, you double its length. Now, that means in general, we see that right here. Here's a vector v, and I multiply it by 2, and I get 2v, and it's all very cool and awesome. It's pretty simple. And that leads us to a theorem that the length of the vector cv is equal to the absolute value of c times the length of vector v. And how do we prove that? Very simply, I think all the steps are right here, that the length of CV is equal to CB1 squared plus CB2 squared, blah, blah, blah. Factor out the C squared, pull it out of the square root, and pow, it's very simple and easy to prove. This leads us to a definition of a unit vector. A unit vector is a vector whose length is 1. Any vector, if the length of the vector is 1, then it's called a unit vector. And a theorem, a very simple theorem, that if V is a given vector, then V divided by the length of V is a unit vector in the direction of V. And this is pretty, well, I'm only going to prove it if somebody asks me to prove it, but I think it's pretty straightforward. But that does mean that if I would ask you to find a unit vector that is in the direction of 2, 3, 4, all you would do, and I think you can figure it out by yourself. I'm going to pause the video. Okay, enough pausing. The length of 2, 3, 4 is square root of 29. And that means the U is for unit. The unit vector that's in the direction of 2, 3, 4 would be 2, 3, 4 divided by root 29. Another way you could express the same answer is 1 over rad 29 times 2, 3, 4. Same thing. That's it. Yay! Unit vectors, all that.